Okay, welcome everyone. I'm John Pretty. I'm going to be talking today about a library I've been working on for the last few months called Contextual. I can't really see there. The lights up here are so bright, but I'm going to ask you anyway. How many people here have come because they know a little bit about Contextual already? Very few, I think. Very hard to tell as well. So this library arose as a result of an earlier talk I was giving about interpolating strings in Scala and how you can use the type system and macros and other complicated things inside the compiler to do some quite clever things and, given an interpolated string, check its contents at compile time with a macro. And I gave this talk at Scala I/O in Paris at the end of last year, and nobody understood it. And this was a bit of a problem. And I realized afterwards that trying to fit all of these quite complicated and quite subtle ideas into what was a 45-minute talk was never going to succeed. So instead, I thought, well, okay, I'll just take all these ideas, I'll roll them into a library, and I'll make them easy to understand. And that became Contextual. So I'll start at the beginning and tell you what it is. I know I haven't really explained what Contextual is yet, but hopefully you'll be familiar with code like this. All we're doing here is we're substituting a string into another string using the S interpolator. So is anyone here at all confused by this? This should all be very familiar. Okay? So what happens is whatever type name happens to be, it gets substituted into that string in that position, has toString called on it, and in this case it starts off as a string, so nothing interesting happens there. And we end up with the string being returned, hello, John. So far, so good. But not very exciting. In fact, very boring. So the reasons why I don't find this particular example interesting, even though it's the most familiar occurrence of interpolated strings in Scala, you can put any type. You can substitute any type into that. My example was a string, but you can put whatever you like in there, and it'll just have toString called on it. So the embedding type is any. And the return type is always string. Nothing exciting about strings, nothing particularly type-safe about strings. And this third point here is maybe you would take this for granted. Maybe it's just a little bit obvious, but the literal parts, so the parts of that interpolated string that aren't variables, that aren't substitutions, they can contain anything. You're probably thinking, well, they're strings, of course they can contain anything. Well, maybe there's an alternative. Maybe we can actually disallow certain things, and maybe we can get some use out of that. So that's a hint as to where we can possibly go with this. So when the compiler sees code like this S interpolator, the first line here, before typing, so you probably know the compiler has several phases. So it starts off with source code and ends up with bytecode. And along the way, it does various transformations of ASTs and so on to get to that end goal. It starts off early on with parsing, and then a little bit later it does typing. And during this very early phase of parsing, this first line here gets transformed into the second line. So in the typer, and the typer is where most of the time is spent in the compiler, where most of the interesting work is done, where most of the errors will occur, the compile errors will occur if there are any. The typer only sees that second line there. It sees the creation of a new string context object with the parameters, hello and exclamation mark, and they come from the green parts on the top line. If you had more substitutions, there would be more parameters. And it calls .s, and s is the name of the interpolator. So whatever prefix you put in front of that string ends up as a method invocation on that string context. And as a parameter, or as multiple parameters to this S method, we have all of the substitutions. Now, this is a very simple expression, but it can be any expression you choose to put inside the string after an exclamation, after a dollar sign. So this transformation happens in the parser. The parser is not very intelligent. The transformation is very dumb. It does the same thing every time. If you wrote Z instead of S, you get a Z there. And that is what the typer will see. So consequently, can anybody tell me what this does if you type this into a REPL? There's no prelude, you just type this straight into a REPL. Shout out if you know the answer. I'll give you a couple of seconds. Shout loud and confidently if you... True, someone said true. Correct. Why is it true? Well, it gets desugared. That equals becomes a method invocation on a newly constructed string context object. Sorry, I haven't got a laser pointer, you're just going to have to follow my finger. And we put a string context after the dollar in there, so that gets moved over to the parameter to equals, and I carefully constructed it to have exactly the same parameters as the literals either side of that, so that they would be the same. And because string context is a case class, its equals method is defined to be based on the parameters. So those two are equals, and we get true. Maybe that's not what you would expect. Maybe you'd expect that to be some sort of failure. But as I said, the desugaring happens. It happens in a very dumb way, and we can therefore rely on it to happen in that same way every single time. So all we need to do if we're writing our own interpolator is we need to make that desugared version of the code compile. So this is what Contextual takes advantage of. So given that, how would we make some desugared code compile? Well, one thing to do would be to make sure that method invocation will work. And string context obviously has a fixed set of methods defined on it. So in order to have that, what appears to be a method invocation work on a newly constructed string context, we need to use extension methods. Who is not familiar with extension methods in Scala? I can't see any hands up, but I can't see anything at all with these lights. So I'm taking from that most people are familiar with them. So we use implicit classes to provide additional methods or to decorate a particular type with additional methods on that type. And we can use that to effectively add methods to a string context. So we can add a method basically with the same name as the prefix we want to use. And that method is literally just a method, so we can change the return type. If we wanted to, we could change the number of parameters, the types of those parameters. So remember with the S interpolator, it's just any, but we could have the first one be an int, the second one be a string, and you would only be allowed to substitute an int followed by a string in your interpolated string, if that's the case. Or, because it is basically an orthogonal feature to the desugaring, we could implement that method with a macro. And this is where it gets exciting. Now that is all I'm really going to say about macros. Contextual is implemented with a macro, but don't switch off because I'm not going to talk about anything that requires any knowledge of macros. The beauty of this is that you don't need to work with macros in order to take advantage of the features that Contextual gives you. So let's say we wanted to, let's just revisit this simple S interpolator. We create a decorator on string context. This is our extension method. So def sub. What we want to do is have this bottom line here compile. So we define sub decorating the string context, and we implement that sub method with this longest line here, context.parts. This parts method comes from the original string context, and it gives us the literal parts. Now, there's a very important distinction to make throughout the rest of this talk between the literal parts of a string context and the substitutions, which, as far as compile time is concerned, those substitutions are holes because we don't know what they are. We don't know what the content is. At compile time, we know what the literals contain. We know the exact string values of those. And here we're taking the parts, the literal parts, and we're interspersing them using the little-known intersperse method on the collections library. Little known because it doesn't actually exist, but it illustrates the point. We intersperse them with the parameters, the substitutions. We're mapping toString on all of those. They're just typed as any, so we can do that. And then we make the whole thing into a single string. So I didn't want to write it in the long form because it sort of distracts from what it's actually doing. We are literally interspersing them. So let's pretend that exists for the purpose of this example. So that's how we would do a simple runtime interpolator. But what contextual does is it gives you the ability to take some arbitrary code that you write, so any code, and it gives you access to the static literal parts of the interpolated string so that you can look at them, you can parse them, you can run a regular expression on them. You could do anything you like, anything that you can write in code, you can do with those literal parts, and that will be run at compile time. And then for each hole, now the holes are kind of the difficult bit because we really don't know what's in them at compile time when we're doing this. So we can assign a context to each hole. I'll talk more about what a context is, but think of it now as like an enumerated value describing what sorts of things can go in that hole. The idea being that we will later constrain them. One way we can constrain them is that we can restrict which types can be substituted in which holes, or which contexts. And we also can give different ways of interpreting different types being substituted into different contexts. So the usefulness of all these different combinations will become apparent when I give you a couple of examples. But it turns out that it's both possible and for certain kinds of interpolators, it's a necessary requirement. And one thing which I thought was very important, often when you're writing a library like this, which is interpolating strings, you want to be able to support types which you haven't yet considered. You want to be able to support types which your downstream users may want to substitute into the interpolator. So we use type classes to do this, and it is fully extensible. So there's a few examples here. URLs, URIs, file paths, class paths, these can all be included. JavaScript, Lisp, Haskell, JS, so good they listed it twice. I'll delete that for next time. You could embed Scala inside Scala. You could put a regular expression in an interpolated string and have it checked. User-facing messages. Actually, I've got some more specific examples of these. How am I doing for time? Oh, I'm early. Yeah, I'm ahead of schedule. Check. Yeah, we just pause a bit so this slide becomes correct. We could embed a date and a time in a string, and we could check that they are the right format. We could check that is a valid time zone. We could check that the three letters in the middle are a valid month name. We could include a URL, make sure that the scheme is in the correct format, that it has the right number of slashes in the right places. For a file, you could, if you wanted to, write an interpolator that checks whether the file actually exists on your current system. Now, maybe that's not that useful if you want to distribute your code elsewhere, but if you know it's only running locally, you could write an interpolator that adds that constraint. So it checks that file exists before compiling the code. Or conversely, it refuses to compile unless it knows that file is present. Maybe more reliable would be the class path. So if a file or resource exists on the class path, we're good to compile that. If not, we throw a compile error. There's some Haskell. We could compile this and end up with, we could actually fork out to GHC, parsing this code, checking it works. If it returns any errors, then we could report them back through Scala's error message system, or compile error message system. So these are all possibilities. A lot of these haven't been implemented. Some of them have. Regular expressions. These I've given 2 examples there. The first one should compile, I think. The second one, maybe we would like to fail during compilation because there's no closing parenthesis. User-facing messages. We could even check these. We could provide the compiler with a dictionary, and we could identify that I've misspelt occurred. And this could be an error. We could actually say no spelling mistakes in our user-facing code, provided they're in strings that are prefixed with message, for example. JSON, you've probably seen things like this before. Rapture JSON always used to do this, and this can now be generalized into a contextual interpolator. Same thing with XML or YAML. Obviously, the second example there shouldn't compile. No, we've also got a substitution in there, so we can place a value called foo in that position. That's fine. Now this one, this is actually something which came about when I was working on the Scala World website last year. Obviously, there's another plug for Scala World here. You should all come. But I was working late at night, and I had a problem which I'll show you in a second. But we have several interpolators here. We have an ID, so maybe that one is checked to make sure it doesn't contain spaces or characters that aren't supported in IDs. We have a CSS size, so we could check that that's in the valid format. It's a number with valid units. And then we could have some CSS, a fragment of CSS which refers to the ID. So I've said $grid. By the way, how many people here have had the misfortune to use CSS at some point in their careers? Okay, you've all suffered. So this will make it. I mean, if this gets some adoption, then you could all remove this a lot of the pain of CSS. So we can refer to the ID by a substitution. So we're using $grid, which means that it's difficult to misspell that. The compiler will tell us if we're referring to something which doesn't exist. And in the HTML example below. Actually, I haven't used it there, but we could refer to ID equals $grid down there, and that would also make sure that we are cross-referencing these 2 things, and the compiler is checking them. So there's also an opportunity for interop between different interpolators. We could also check that font -size is a valid property for CSS, and that the parameter that's passed to that is a valid size. I don't know why size shouldn't be a double, actually. Ignore that double type description there. That should be a size. Does that all make some sense? Now, if you think about how this would be implemented, the CSS interpolator would be able to read the contents of this CSS string here, and anything you can work out just by parsing and checking a list of valid properties and the types that are associated with those can be done with contextual. Okay, so this is what I didn't have when I was working on the old Scala World website. And instead I was just using plain CSS. And I later discovered, I accidentally deleted a closing brace from one of my style sheet definitions. And what happened was this. This abomination. This is Miles Savin's dog. This is John DeGoe's, freshly licked, it seems. There is a whole mess of text around that. I mean, this is the venue that we have for Scala. Well, like, there's a bit of it over there and a bit over there. The bit at the top looks okay. I mean, that was almost intentional. But the whole thing is a horrible abomination just because I accidentally deleted a closing brace and half of the style definitions on the page got deleted. Now, if if I'd embedded that in an interpolated string and checked that with a CSS parser, which I have all the information available at compile time to do that, then this could have been avoided. You could have avoided having ever seen this, and you would have been all the better for it. So I'm going to look at an example in a little bit more detail. I'll run through quite quickly, but XML, I know probably many of you, maybe many of you are forced to use XML, but and you'd maybe use something like JSON instead if you could. But I think everybody here is at least familiar with what XML looks like, and some of the constraints you get on what is valid XML and what is not. So here's an example. We can embed a string inside some foo tags in XML. That works fine. We've got no problem there. We could maybe try and embed an exception, but we don't want to allow that. So contextual gives you a way to prevent a substitution of a type that we don't really have a good interpretation of inside XML. We can prevent that from being embedded. By the way, this is in a library called Xylophone, which I've been working on as a... I guess it's my sort of real-world implementation of a sort of more than a trivial contextual interpolator. So this is an interpolator for XML, which I've given its own library. It's open source, and you can check it on my GitHub account. So this second line here, we are not going to accept. This is a compile error. For parsing, these two are both fine. We check that they're well-formed. We check that the tags match up. We check that there's nothing inappropriate in the wrong places. However, if, for example, we miss the closing tag of bar, we get an error here, and the error would point at the position where it first identifies that this is not valid. In the second line, baz is not in quotes, so this is not valid. And this last line looks kind of okay until you consider that less than symbol is starting to look like an opening tag, at least to a parser, so we don't allow this. Now this, you might accidentally copy-paste, or at least the expression 1 is less than or equal to 2. You might accidentally copy-paste this into the code, and you maybe wouldn't notice until you come to parse it at runtime that this is a problem. So contextual will stop you. What's wrong with this one? If you did simple string substitution, content, you put that in place there, this would actually work, you might assume. But remember, at compile time, we don't know that, I mean, in the general case, we don't know that a variable, this one happens to work, but at the general variable, we don't know that it contains content which just happens to close that opening tag. So although this would work with simple string substitution, in the general case, we don't know that, so we forbid that at compile time. Have you all seen enough XML yet? We're nearly there. Conversely, if you embedded that in a position where it would be invalid, that is actually fine by contextual's standards because it knows that it needs to escape the closing angle bracket. So the interpretation of the substitution can differ depending on the context. So here we're going to embed my name into several positions in some XML here. The second line, we can actually, despite the lack of quotes, we can unambiguously interpret that. We know the only possible way that could make sense, which is to, when we do the substitution, because we know it's a string, we just put quotes around it. So that's fine. But the very next line is basically the same, except the quotes are already there for us. So we need a way to make both of these work, because, I mean, we can both of these can be unambiguously interpreted, I think. So the answer is that these two, the first two substitutions there, have different contexts because they're in different positions. One is inside quotes, one is immediately after the equal sign for an attribute. Both are valid, but the interpretation of the substitution is different. The last two are pretty straightforward. In the general case, we don't know that we can substitute a name in a self-closing tag. I mean, string substitution would work again, but in the general case, we don't know that. Now, if you wanted to extend this is a sort of bit of a preview as to what you could do as a user of Xylophone. Say you had a record type. I don't know what the record type is. It's your own user-defined type. So maybe in the companion object to that record, you would like to provide a type class instance which determines how that is embedded in a substitution. And the way you write this, there is some neat syntax which maybe looks a little bit alien. It's meant to appear to be like a match block. Instead of case, we say on. Now, body and attribute both refer to contexts. So if you're in body position, so XML body, not inside a tag, then get the name value from this record type. Whereas if you are substituting a record type in attribute position, we're going to interpret it differently. We're going to just take the ID. ID is an integer, so we'll call toString on that, so we get a string. Now, the types involved are quite complicated with this, but the nice thing is that you don't need to see them, at least not until that implicit type, implicit val there requires a type description, which is going to be something in a later version of Scala, so we'll have to find a way to work around that. But the embed method there produces something with a complicated type which gives contextual exactly what it needs at compile time to know that this is a valid specification for how you embed a record in body position and in attribute position. Okay, so what I'm saying here is don't look at the ugly details, and you don't need to see the details. This is what you write if you want to do to do a substitution. And in itself, it's quite neat. You can even do a type class based embedding, so you can embed anything that itself can be shown, so anything which has a show type class. So that's a little bit more complicated, but basically we're calling, we're sort of using the show type class to get a string from some type T, which remains abstract for this definition, and we can then embed anything showable inside an interpolated string. So I'm going to spend the rest of the talk going through creating your own interpolator. And I did this at LambdaConf, so I've forgotten to change that URL at the bottom. That was my example. But what I want to create, and there's about 7 steps, is a URL interpolator that will check the contents of this string and will check that the substitution for page is appropriate. So step 1, I will just talk through each step in detail later, but very quickly, we're going to create the interpolator. That's an object. We want to bind that newly created interpolator to some prefix. In this case, it'll be URL. We're then going to write some code which checks the content of that string, or at least checks the literal parts, the bits that we know at compile time. Then we're going to define some context, some possible context that you might make a substitution in. Some of them will be valid, some of them will not be valid. And then for each hole, now here there is only one hole, it is where the word, the expression page is. For every hole, we will assign a context to that. So maybe the context we want here is going to be path position. And then we need to define how that evaluates at runtime. So everything I've talked about so far is sort of more focused on the compile time. It's focused on how we interpret this during compilation. We don't talk about, well, actually we need to get an object out of this at the end of it. So assuming it passes compilation, we then need to evaluate it. And then, as you saw on the previous couple of slides, we want to define how certain types can be embedded in that interpolator. So this is really easy. Step one, we just create an object, and it extends Interpolator, which comes from Contextual. That's it. Though I will add some more contents to this object in a second. Here we're going to use an extension method on string context. It's actually an extension field. And this is actually where the macro gets expanded. You don't need to see that. This is all you need to write. And there's two things you probably need to change. You need to change the name of the val to the name of the prefix you want. And you need to change the name of the interpolator object that you bind it to. Otherwise, just copy-paste this and just change those two. So that's really easy. And then we're going to write the code that actually checks what is in the interpolated string. And we have access to all the literals here. All the literal parts, all the statically known literals. We just call the literals method of the context, CTX, parameter to, the method we're implementing is called contextualize, which is where the library gets its name from. But we're going to implement that with code which checks that those string literals contain whatever we want them to, or report an error if they don't. And this code has access to a list of strings. So anything you can do with a list of strings, you can do at compile time with just by putting it into this contextualize method. So this could be anything from, one possibility, if you wanted to, is you could take you could check whether the list contains just one value, and that means there are no holes, and the whole thing is just a static URL. And then you could actually say, well, I'm going to send a request to that URL at compile time. Bear with me on this. And if you get a 404 back, you could say, well, actually, maybe you've got a broken link in your code. That is a possibility. If you can do it at runtime, you can do it at compile time with contextual. And then we have to return nil. Well, sorry. In the case where we have no holes, we will return nil. I'll show you the more interesting case in a second. By the way, it might be worth thinking while I'm talking about this, if there's some sort of DSL you all work with in your day jobs frequently, especially if it's one that you often get runtime errors with when that DSL gets parsed or it refers to things which don't exist. Have a think about how you might implement that or implement an interpolator for that with contextual. So that last slide was sort of the happy path where we never have any failures. But what happens if we do? We want to report back to the user some error message. Now, I'm assuming the existence of a url.parse method, which I'm calling around the middle there. Let's assume for this simplified example that there is only one. The list of literals contains only a single value, i.e. there are no holes. Let's assume that, and we just try and parse that URL to make sure it's valid. And our parse method either returns none if it's a valid URL, or it reports that there's a parsing error, and we can look at that. This all looks like very runtime code, but we're going to run it at compile time, which means we can abort. We can abort the entire compilation just because this URL is not valid. And we pass it three parameters: the literal where the problem is occurring, the offset into that. So when you get a compile error, you normally get a little caret, little Chinese hat symbol, circumflex, which points at the compiler's best guess as to where the error is. You can decide where that goes. So you can pick the offset. That's just an integer, and you can report the message that the user sees. That can be as long or short as you like. So we've now got an interface to reporting compile errors that doesn't appear to have any real complicated interaction with compiler APIs. So that's nice. Then remember, none is the happy path, and we're just going to return nil for now. Now let's dissect this URL. In red, there is the scheme. So let's say that is one context. Then there's a domain name. Then slash, then there's a path in green. And then maybe we have query parameters. So maybe there's a series of keys and values. There can be multiple keys. I mean, I've only got one example here, Q, but there could be many of those. And for each of those, we can create a case object which extends the sealed trait. And we are just here defining all the possible contexts in that string. So any position you decide to make a substitution, we can work out what the context would be. And what we're going to do, at compile time, we're going to execute code like you saw 2 slides ago, where we run URL parse. And we're going to have to somehow, and I don't want to talk in any detail about how you might do this, because whatever DSL you're using, it'll have a different way of doing the analysis to decide what the context for each hole is. But we're going to do that analysis, and at the end of it, we will return a list in order with a one-to-one mapping for each of the holes. So we're going to say, in this example, the first hole has, where we've got the path parameter here, that has context path, as defined on the previous slide, and value has, unsurprisingly, value context. So given that, we've given the compiler information about, a little bit of information about how we expect it to interpret certain types and certain values in those positions. And then, like I said, we need to have some way of actually creating this object. We need to return something from this interpolated string. So when we write code like the very first line on the screen there, what do we want to get back? Well, there is part of the standard library. There is the Java.net URL factory. So let's just use that because I can't think of a good reason, actually. Well, we're going to use that. So we can, as long as we can implement this method here, we have access to all of the parts of the interpolated string now, not just the static literal ones. We're now in runtime, so the evaluate method has runtime information. It actually has access to the evaluated expressions that get substituted. So we have access to everything now. We have a superset of the information we had at compile time, and we can just create a new URL from that, and therefore the return type of this URL interpolator will be a Java.net URL. This is very similar to what we saw before. So depending on the context, we want to make the substitution of a type in a particular way. Now, paths, keys, and values, these all need to be URL encoded. So we define these lambdas here that describe how that substitution will take place. Now, this is defined in the library, which is quite useful because it means users of that library, they don't have a good way to make an injection attack if they wanted to. If you tried to substitute a string, a bare string, into an interpolated URL, for example, the library is defining how you do the encodings, how you do the embeddings. It doesn't require you as the user to define at the call site how the escaping works. So that's quite nice. It makes it actually impossible to do unless you try very hard to circumvent it. For the domain, I mean, maybe we shouldn't really have domain listed there, because in the general case, I mean, we can. What I've done here is I've made the domain lowercase. I've removed all the uninteresting characters. sorry, all the interesting characters, left the uninteresting ones. But there's no real canonical way to substitute a string into a domain name. So in this particular example, maybe it would be better if we just deleted that domain case there, and then users would be prevented from making any substitution in domain position. This is more of a subtlety of contextual. We've assumed generally input types to be strings. I mean, the whole thing is a string in all cases, but there is the possibility of having different sorts of inputs for different types. Sometimes you maybe want to input structured data. Sometimes you maybe want strings. Sometimes it'll be numerical. Given that we're allowing extensions, we have these type classes that you can implement for extending this. We still need to program our library to an API that we know, we understand fully. So we have to require that our input data, our substitutions, arrive to us as the library, as library writers, in a type that we can understand. So maybe it's string, maybe it's a more complicated type. This is something that would become apparent after you'd probably worked with trying to implement a DSL for a little while. I will not talk about it for much longer because it's I wasn't going to do this. Let's just skip that. Yeah, the truth is, you can't handle the truth. There is a horrible macro behind contextual, which I am trying my best to shield you from. The macro itself uses runtime reflection at compile time, if you can imagine that. So yeah, I've got some speakers notes here. I'm just not going to. It's not worth it. So I'm getting close to the end anyway. So just to summarize, with contextual, it's possible to define interpolators for your own custom types in Scala, and it provides keyword extensible API for defining where, when, and how types can be substituted into them. It's really worth saying that most of the complexity, I mean, if you've seen the last few slides and you thought, oh, this is really complicated, many uses don't require substitutions, and if you can avoid substitutions in your particular DSL, then life is a whole lot easier. You only need to do about three of those 7 steps. But the contextual does allow you these more complex cases. Or we can phrase that maybe in the converse. A library built with contextual can make it impossible to write instances of some type which should simply not exist. Now, this is something I fundamentally believe. Types should not have content, or we should not have code which tries to create types which are not representable. We shouldn't have code which gets compiled which says url.parse x, where x is a string. It's not a valid URL. The compiler has all the information it needs to know that that is not valid. So I want to go as far as I can to stop that compiling. And contextual is the means, or one means, of helping towards that goal. So that is basically the end of the presentation. The latest release is 1.0.1, but I am working on a breaking release, which is version 2.0. It's version 2 not because it's significantly different. It's 2 because it just has some breakages in the API, and I'm not precious about my version numbers. So by the end of the year, it might be 4 or 8 or something. So that is available for every combination of Scala 2.10, 2.11, 2.12 for those 3 platforms there that actually works. I mean, that actually exists. It works on Scala Native 2.11 and Scala JS 2.11 and 2.12. The website is hopefully easy to remember. It's just contextual with a dot, 2 characters in and 2 characters from the end, because we have .al domain names. And there's a Gitter channel. I'm in there most of the time. If I'm not, you can ping me on Twitter at the address at the bottom. And you can look at the source code. It's all open source. It's all. I'm quite proud of it. It's actually, of all the projects I've worked on, it's the first one that's well documented. And it's taken me 10 years to actually write some documented code. And Contextual does have full Scala docs, which are on the website. So that is all I've got. I don't know if I have time for questions. We've got the panel in here starting in about 15 minutes, I think. So maybe I can take questions until 12:30, so 3 minutes.
Hi, yeah. One of the more kind of hard to work around issues with specifically the URI interpolation in Rapture has to do with the fact that it uses a white box macro to actually determine the result type of the interpolation. I wonder if you managed to find some unfathomable way to work around that and
right.
Somehow.
Yeah. So this is a good question. So Tommy has used my previous library, Rapture, which contains many different things. One of which is an interpolator for URIs, which looks at the content of the interpolator string and determines the return type on the basis of the content. So everything I've described in the talk so far assumes there is a fixed return type. Contextual does give you some additional methods which you can override to change the return type, or make the return type variable dependent on the content. But it also has a type member, an abstract type member, which was added mainly, not for my benefit, but for users of IDEs who want a sensible return type to be inferred from a white box macro. So you can include an upper bound on the type, and your IDE will be able to interpret that. Were you asking the question partly because you've used that with an IDE and the IDE gets confused?
Well, I used that as an example of IDEs being confused about macros.
Right. Okay.
In the talk yesterday, but yeah, same principle.
I didn't answer the question before. It is actually a white box macro, but it shouldn't have the problem of IDEs struggling to work out the return type, provided all your return types are subtypes of some common type. Cool. If they are completely distinct types, then you're out of luck. But Contextual does give you the option of doing that. Seth?
Can you contrast Xylophone to the XML Interpolator work happening at EPFL?
I don't know much about what's happened with the interpolation of XML as developed at EPFL. I think it was a Google Summer of Code project. What I do know is that as much effort as possible has gone to make the EPFL version bug compatible with Scala XML, as has existed since 2004, 2003.
I assume you consider that a non-goal.
So I have introduced my own bugs in Xylophone. They're new. They're different from the ones in they're different from the ones in Scala XML, but they can be fixed, and I am not precious about keeping them in the long term. In fact, I would love to have many of them removed. I think the EPFL one is more advanced in its, development is more advanced, it's more complete. Xylophone, I intend later to be a lot more like many of the JSON libraries for Scala, but for XML. I did actually do an experiment with Rapture. Rapture has an had a JSON module, and I thought back then maybe I could try to shoehorn XML into working with the same mechanisms that Rapture JSON used, and it was kind of a failure with Rapture. So I decided that I would just re-implement all of that. So what I want to have is sort of generic derivation for Xylophone. serializing case classes to XML, all of the sorts of things you would like to do with JSON, but instead for XML. That is more of a long-term goal. It depends on my time for completing it, but there's a lot done already. It's just there's a long way to go, and it's probably more ambitious. I'm probably out of time, over time, so I'll just say thank you for coming, thank you for listening, and stay here for the panel, which is starting in probably about 10 minutes. I will be around as much as I can for the remainder of the conference, not much left. But do come and talk to me and ask me anything about contextual, or check up on the Gitter channel. So thank you very much.